Alright, so today we're going to expand on our knowledge of lines and we're going to talk about something called systems of equations. And all systems of equations is that we have two separate line equations that we want to find one solution for if possible. Okay? So it's no different than anything else we've done. We have a line here. We have another line here, and what we want to see graphically is where they cross if they do. So let's talk about this on a graphic type of thing. We have three different types of scenarios we're going to run into with the system. Right. We're going to have one line and another line, and at some point they're going to meet. Okay, this is our one solution scenario where there is one point that satisfies both equations in the form of x comma y. So there's some point x comma y that the values are true for both of these equations. So that means they cross at that point. The second scenario is if we have a line and then we have another line running parallel to it. Right. At this point, these two lines never cross. They never meet each other. This is our no solution scenario. Okay, which means there is no one point xy that is going to satisfy these equations because they never touch each other. Our third scenario is we can have a line, and then the second line is actually the same line that graphs right on top of it. Okay. This means that every solution for the first line is a solution for the second line. So we have kind of an infinite number of solutions because they're the same line. So there's all these points all along the line that are solutions for these two equations. All right, and so this is sometimes called all solutions or all real solutions. But what we want to know is there's definitely more than one. There's definitely more than two. There's definitely more than 1,000. There's more than 1,000,000. Every point for one line is the solution for the second. What we really want to do is go back to our basics. So when we first started graphing lines, we said, okay, here's a line. And what I want to do is I want to see if the ordered pair given is a solution. And what we did is we took the ordered pair given, we plugged it into an equation, and we see if it was true or false. But now instead of doing it for one, we're going to have to do it for both. So I'm going to go ahead and number these equations 1 and 2 for ease. And the first thing we want to do is say, okay, we want to take the first solution, equation 1. So we have negative x plus y is equal to 2. And we want to plug in the values for x and y. So x is negative 1. Y is 1. And we just want to go ahead and see if this is a true or false statement. So remember, a negative and a negative give me a positive, so this is 1. Plus 1 is equal to 2. 1 plus 1 is 2. 2 is equal to 2. This is a true statement. So equation 1, this works. We can't just assume that equation 2 is also going to be true, so we have to try it out. So let's do equation 2. So we have 2x minus y is equal to negative 3. And where our x and y is, we're going to plug in our values, negative 1 and positive 1. And I have 2 times negative 1, which is negative 2, minus 1. Remember, this is negative 2, same as saying a plus a negative 1 for those of you struggling with the integers. and this should be equal to -3. So I spend $2, I spend another $1, I spend $3. That is equal to -3. This is also true. So this is a solution. But remember, it has to satisfy both equations in order for it to be a solution. Okay. Let's go ahead and look at another example here. This is example 2. And we're going to do the exact same thing. So I'm going to go ahead and number them at 1 and 2. Sorry. And I'm going to go ahead and plug it in. So I have solution 1, or equation 1 is 5 times x plus 3 times y is equal to -1. And my x and y are -2, 3. So x is -2, y is 3. And I have positive 5 times -2, which is -10, plus 3 times 3, which is 9. I spend $10, I only have 9, which means I still owe somebody $1. Okay, so this is a true statement. Remember, again, we can't assume that they're both true. We have to try them both. So let's look at equation 2. I have x minus y is equal to 1. Plugging in my values, I have -2 and 3. And I have -2 minus 3 is equal to 1. Well, all I'm doing over here is -2 minus 3 is the same as plus -3, right? So I have -5 equal to positive 1. This is not true, so this is false. All right, so this is not a solution. All right, and we're going to look more at systems in a separate video, but this is kind of an introduction, so you kind of see what we're getting into. We're going to look at 3 different ways to go ahead and solve these systems. But right now, we're trying to figure out if the system is true or it's false for the given values. See you in the next video.